Do you know what's fun? Realizing that your boring little home network, yes, yours, is basically wide open to advertisers, trackers, app developers, and IoT devices like smart TVs. They're loading you up with ads and tracking your activity, all while your ISP quietly siphons your DNS traffic like a raccoon digging through a dumpster. But you know what's more fun? Stopping them. Today I'm going to show you how to build your very own DNS filtering system using a Raspberry Pi and Pi-hole. It works on every device in your house, doesn't need a subscription, and blocks a shocking amount of garbage. And if you want to go full wizard mode, we'll also add a self-hosted recursive DNS resolver using Unbound. Also free. No cloud, no selling your DNS data, no, we'll promise we don't log anything, but we totally do. Let's do this. Welcome back to Dad Explains Everything. Recently, I explained the levels of DNS filtering, from on-device setups to router-level filtering to network-wide solutions. And in that video, I promised a full walkthrough of the self-hosted option. And here we are. Now, I did ask you all to vote between Pi-hole and AdGuard Home, and you did vote, just in a way that made it mathematically impossible to figure out who won. So guess what? I'm making both videos. This one is Pi-hole, and the next one will be AdGuard Home. And while I freely admit that AdGuard Home is easier and probably the better product, Pi-hole is still my personal favorite. Why? Honestly, I've used it for years. It's not owned by a company that might someday become Norton AdGuard Home Deluxe, now with AI ads. And the project is supported entirely by donations. So today you're going to prepare a Raspberry Pi, install Raspberry Pi OS, install Pi-hole, configure it, test it, and optionally add Unbound. And yes, you can absolutely do all of this even if you've never touched Linux before. If you can follow a cooking recipe, you can follow this. And unlike cooking, nothing here will catch fire. You've got this, and I've got you. After all, what are dads for? Let's get started. I've got a helpful worksheet linked in the video description below. I recommend printing it out as there are things you'll want to write down during this process, and I've left spaces for the entries. It's also nice to cross things off as you go. I would also leave it on screen because you can copy and paste all of the stuff you need to otherwise type. I've tried to make this as easy as possible, but sometimes things happen. And if anything goes sideways, drop me a comment and I'll try to help everyone that asks for it. While you technically don't need to watch this video if you have the worksheet, it does make it way easier to see what you're supposed to be looking at and to verify that everything is going as it should. First, you'll also need some hardware. In order to use this tutorial as is, you'll need a Raspberry Pi 3B or better, and wired Ethernet is recommended. You'll also need a micro SD card, 8 GB or larger, a micro SD reader or an SD reader with a micro SD adapter, a regular computer or laptop to flash the SD card. This can be a Windows, Mac OS, or Linux computer. And admin access to your router if you want to use the Pi-hole automatically across your entire network. Step 1 is to flash Raspberry Pi OS to the micro SD card. To do this, you'll need to download and install the Raspberry Pi Imager from raspberrypi.com on your computer. You can follow the link on the worksheet. Once installed, launch the Raspberry Pi Imager. It's a guided process, and the first prompt is Device. Here you select the type of Raspberry Pi you're going to use. Next is OS, where you'll select Raspberry Pi OS 64-bit. Next is Storage. You'll need an SD card in the reader and the reader attached to your computer. You will select the micro SD card. Next is Customization. Here you'll enter a host name, Pi-hole1 in my case. Then select your country's capital city, time zone, and keyboard layout. In User, you create a username, netserv in my case, and a password. Remember or record the username and password on your printed worksheet. Next is Wi-Fi. I would skip this because you're using wired Ethernet. Then there's Remote Access. You will toggle Enable SSH to on and set it to using password authentication. Next is Raspberry Pi Connect, which you will disable. You will then write the SD card, which took me about 6 minutes, and then verify, which took me about 4 minutes. Your times will vary, and when it's done, eject the card. Now insert the card into the Raspberry Pi, plug in Ethernet, and power it on. After you've given the Raspberry Pi a couple minutes to boot, you'll find its IP. You can find this in your router's client list, or you can ping the hostname that you assigned in Step 1, Number 4. Record this address. Step 2. Updating your Raspberry Pi. You're going to connect to your Raspberry Pi via Secure Shell, or SSH. To do this, you need to open a terminal window on your computer. On a Windows computer, you press the Windows and R keys. When the run prompt comes up, you type cmd and press enter. A command prompt window will appear. In it, you will type SSH followed by a space, then the username from Step 1, Number 6, an @sign, and then the IP address from the end of Step 1. It will look something like this. You'll be prompted for a password, and you'll enter the one that you created in Step 1, Number 6. After that, you'll copy and paste the following from the worksheet or type Step 3. Give the Raspberry Pi a static IP address. In order to be reliably reachable, you will need to make sure that your Raspberry Pi does not have its IP address dynamically change. To do this, you can either reserve the Pi's IP in your router's DHCP maintenance, usually by creating a DHCP reservation or converting the existing DHCP lease into a reservation. This is the preferred method for this tutorial. The alternative is to set a static IP address in the etc dhcp cd.conf file, but this is outside of the scope of this tutorial. I can provide assistance in the comments if anyone wants to go this route. Step 4. Install the latest Pi-hole. Here you'll start Pi-hole's official installer from SSH. You can copy and paste from the worksheet or type the following. During the install, you will confirm a static IP warning. Then you will select an upstream DNS provider. I would select Quad9, the filtered ECS DNSSEC, or pretty much any DNS crypt server if you aren't going to load Unbound. Selecting Google or any other provider is fine if you're going to be loading Unbound later in the install. When prompted for block lists, select Yes to add Stephen Black's unified host list. When asked about enabling logging, select No. Select 0 for privacy mode for FTL, and after install, you can set the password from SSH by copying and pasting from the worksheet or typing sudo pi-hole set password and then whatever you want the password to be. When done, you can test DNS from SSH by copying and pasting from the worksheet or typing dig at the Pi-hole IP address space and then www.google.com. You'll reboot the Pi by copying and pasting from the worksheet or typing sudo shutdown-r now. At this point, you should have a completely bootable Raspberry Pi with Pi-hole installed and updated. As a quick reminder, Pi-hole works by intercepting DNS queries, the "what is the IP of this domain" questions, and refusing to answer anything on its block list. If the request never resolves, the ad or tracker never loads. It's simple, elegant, and effective. Step 5. Set your router to use Pi-hole. On your router, these are the generic steps. 1. You go to the LAN or DHCP settings. 2. You find the DNS server fields for DHCP clients. 3. You set primary DNS to be your Pi-hole's IP address. 4. You leave the secondary DNS blank to force clients to use the Pi-hole. 5. Save and apply your settings. And then 6. Reboot one client device or renew its DHCP lease. To confirm it's using Pi-hole, you can go to the Pi-hole's web UI to see the requests under Query Log. Or, on a client, from a console window, you can copy and paste from the worksheet or type nslookup space amazon.com. If it's able to resolve an address, it's working. Congratulations! Pi-hole is filtering requests for your whole network now. This next step is optional. If you don't want to use third-party DNS resolvers, you can install Unbound to locally resolve DNS requests. Step 6 is adding Unbound and configuring Pi-hole to use Unbound. To install Unbound from SSH, copy and paste from the worksheet or type in sudo apt update. copy and paste from the worksheet, or type sudo apt install -y unbound. To get the current DNS root hints, copy and paste from the worksheet or type sudo curl-o var lib unbound root.hints, then https www.internic.net domain named .root. To configure Unbound, copy and paste from the worksheet or type sudo nano etc unbound unbound.conf.d pi-hole.conf. When the nano editor opens, you'll paste in the configuration from the worksheet. To exit, you'll press Ctrl-X and select Yes to save. To enable and restart Unbound, you'll copy and paste from the worksheet or type sudo systemctl enable Unbound. Then you'll copy and paste from the worksheet or type sudo systemctl restart Unbound. And then you will copy and paste from the worksheet or type sudo systemctl status unbound --no-pager. To test Unbound directly on the Pi, copy and paste from the worksheet or type dig at 127.0.0.1-p 5335 cloudflare.com plus DNSSEC plus multi. To configure Pi-hole to use Unbound, log into Pi-hole Web UI and go to Settings, DNS, Upstream Servers. There you'll uncheck any public upstreams, and in the custom one IPv4, you'll type in 127.0.0.1 pound 5335. Then you'll save. To test from a client console window, copy and paste from the worksheet or type nslookup www.dad-the-engineer.com. From there, you can verify in the Pi-hole Web UI and check the query log to confirm queries went to 127.0.0.1. That's it. You're done. Yes, your configuration is a bit more complex now, but I think it's safe to say that following these steps wasn't hard. At this point, the only real weakness with the setup is the single point of failure with the Pi-hole. If it goes down, the devices on your network will not be able to resolve DNS requests at all. Not good. This is the reason why you typically have more than one DNS server listed. A normal and intuitive thought is that you could specify your Pi-hole as your primary DNS server, while listing a public DNS resolver as the secondary DNS. Unfortunately, that doesn't work the way you might think. Routers don't politely fail over to the secondary DNS, they shotgun your requests to every DNS server you list, and they take the fastest one. That can completely bypass your filtering, and that's not really what we want. But don't worry, this is a solvable problem. Because you know what's better than one Pi-hole? Two Pi-holes. If you're interested in going just a little bit further, you can set up a fault-tolerant, high-uptime configuration of two Pi-holes and Gravity Sync to automatically synchronize their configurations. Aside from repeating the steps from this video, it's less than 5 minutes of additional work to get twin Pi-holes working together. If you want that video, please let me know in the comments below. I will count the individual comments, and not the likes, to figure out if making that video is a good use of time. For what it's worth, high availability configurations are a good idea if you don't live alone. All that said though, Raspberry Pis are very reliable, so having just one shouldn't be a problem either. Even though you're done, there's still something else to cover. I've noticed, in general, that tutorials of this type tend to cover the most difficult technical steps of setting up whatever the tutorial is about. That makes sense, I guess, but the problem is that you didn't assemble a puzzle. Instead, you deployed a network service. And while it's pretty low maintenance, it's not zero maintenance. The companion doc on my site has a section for maintenance and backup, and the section is on the screen now. My recommendations are to use the update commands every month or two, and to export and email yourself a backup of your settings whenever you make configuration changes to your Pi-hole. Depending on how far you decided to follow this tutorial, you should at the very least have a Raspberry Pi running Pi-hole on your network. Hopefully, you were also able to set a static IP or IP address reservation for your Pi-hole, and change your router's DNS settings. If you were not able to accomplish this part, let me know what kind of make and model of router you have in the comments below, as well as where you got stuck. If you were able to successfully configure your router, I hope you didn't stop there. Unbound is less than 5 minutes of additional work, and it's completely worth it. And that's really about as much as I think I can fit into a single tutorial without confusing anyone. If you encountered issues, let me know in the comments and I will do my best to help. And with that, congratulations! You did a thing! You loaded Linux on a single board computer. You loaded a piece of open source software from a command line and you've reclaimed a bit of your privacy. Oh, and you'll see fewer ads. That sounds like a good use of a half an hour to me, and I hope you found it entertaining too. Please share in the comments if you succeeded, how far you went, and if you ran into any issues. If you found this video interesting or helpful, hit like, subscribe, and share this with anyone else that you think hates ads too. If you want to support my work, please hype the video and consider becoming a member. I'm not a big deal, so it's really cheap. The top tier is less cheap, but you do get to talk to me on Discord, so there's that. And speaking of members, I want to thank new members Simon, Adam, A Drifter's Life, Gary, Drew, Chinmoku, Tim, Eric, JMZ, Glenn, Roger, and one more person who will remain nameless for their support. It helps make these videos possible, and members will be automatically entered to win the Raspberry Pi raffle after I complete the AdGuard Home video. If you end up using Pi-hole long term, I encourage you to donate a token amount to their project. Thanks, and have a great and ad-free day.